Welcome to this tutorial on Micromelon coding. This is the very first tutorial and it's an introduction tutorial. Remember that this is not a Micromelon sponsored tutorial and therefore this is my perspective and my views. So once you've installed the latest version, we're going to try the offline version. You'll also need to go to the App Store or download the Google Play version of the simulator. The simulator looks similar to this and it gives you lots of options and choices to test your programming before you may purchase an actual robot itself. It is also very good to test your coding skills with. We're going to start with the free space and we're going to click on the free space and click on play. Now at the moment our robot is not connected, so we need to connect the robot. To do this, we're going to be using the virtual robot, which is 9003. So you type in the name up here, 9003, and then click go, and you see a connection form. If you do not get a connection, you may have to go to simulator and then click on use custom bot ID, and then you can have one generated for you. Once that's done, we can actually start looking at our coding. So let's start with something simple. Let's just move the robot forward and move the robot backwards. So we can start with the blocky just to get started, and then we can actually, as we build our skills, move over into coding in a Python environment on the right hand side. So as you can tell at the moment, I have this split view. So let's start by just going into movement, and what we'll try to do is move forward 10 centimeters at the speed of 15. Now I might slow the robot down a little bit and change it from 15 to 10. And then once it gets to the end, I want to move it back. So I'm just going to highlight Command C, Command V, and then I'm going to tell it to move backwards. Same distance, same speed. You can adjust these if you want, and you can play with the speeds, etc. Now to run your code, you can click Run Code here, and then the simulator will action your code here, or you can actually click Play here and see that it moves forward and back. You can also stop it in either environment, and therefore if you've got it side by side you can easily control the robot. Now we found that 10 centimeters isn't very far at all, so let's move it forward, say 30 centimeters. And up in the code editor, what I'd like to do is also change this, so we're going to move backwards 30 and move forward 30. And you can see the code updating as I do that. So both areas work together. So let's run this now. Very good. If you want to see the top view of the robot, you can click on top and you can look straight down, or you can actually look at the exercise view from an angle. You can also zoom in, or you can zoom out, but it all depends on which version or which layout you like. If you click rewind, it resets the robot and we can run the code again. And as you notice, the robot did not come back directly to the same point. This may also occur with your physical robot. And that's why we're going to be using sensors to help guide our robot and make it more intelligent. Okay, if you think you've got that, how about you try getting your robot to drive in a straight line, turn around and drive back to where it started, turn around and face where it's going forward. So pause this video and give that a go. Here's my solution. Did you do this the first time? Where it drove forward, turned around 180 degrees, and then you left the code for it to go backwards 180 degrees and then turn around again. So sometimes in our coding, it's all trial and error. So we may have to do some adjustments here. So you can either do it down in the code itself, or you can actually do it here. So because we've actually turned around at 180 degrees, we just need to move this minus sign here, and let's see how our robot goes now. Let's reset our robot and let's run our program. So just remember that programming is all trial and error. Alright, let's have a look at the next task. Can you make the robot travel in a square. So go forward, turn 90 degrees, go forward, turn 90 degrees, go forward, turn 90 degrees, go forward, turn 90 degrees. Pause the video, give it a go, see how you go. Now, did your code look something like this? Now on the right hand side you can actually see the code stepping through. Now this is very sequential. So in other words, it goes line by line and executes the instructions that are there. And it's effective. To the end user, it's able to get the result that's required, but it's not the most efficient way of coding. Because you can see the repeated pattern in here. So notice we go forward and we turn, we go forward and we turn, we go forward, we turn, we go forward, return. And we basically do these two lines 4 times. Therefore, we can actually start using a loop. And because we know we're going to do it 4 times, we can actually use a fixed loop. So I'm just going to take those away and throw it away. And then what I'm going to do is place those inside the loop and put our loop on the start and change it from 10 to 4. Now notice the length of our code now. See, our old code is 8 lines. Our new code is done in 3 lines. So let's see if it gives us the same result. Let's go execute the code. Now you can see the code stepping through 4 times, and it's a lot more efficient because there's less lines of code, which means if it was stored onto an IoT device, it would not need so much memory or ROM to store it. Okay, so that's your introduction to Micromelons. I hope you found this useful. If you did, subscribe, give it a like. Also, put a comment in for the algorithm to keep it happy, and have a look around my YouTube channel for other useful Micromelon tutorials.